Okay, let's take a look at this. A function f of x is shown in purple. No, come on! Alright, sorry. So f of x is in purple. The sliding green window may contain the section of its derivative, f prime of x. Where does the function sliding window? Okay, so if purple is the original, then what I'm just going to do, I'm going to go through and look at the slope here and then plot it in green and see if it matches up somewhere. So first, the slope, because it's the original, if I'm looking at the original, I think about the slope, and then I graph the slope as a y value for the derivative. So here, between x equals 0 and x equals 2, the slope is 0. So that means I change to graph the derivative, I make a y value of 0. That's an open circle. And so that would be the derivative there. That's also an open circle, but you can't tell. So that would be the derivative there. That's not that. It doesn't match up with our sliding window. So I'm going to keep going. I'm going to look at this and think of the slope. Whoa, it's a constant slope. What is it? Is that down 1 over 2? Yeah, down 1 over 2. So that slope is negative 1/2. So to graph the derivative, I make a y value that's negative 1/2. So here, negative 1/2. That would be there. I open circles at the end. That doesn't match up with my green window. So I'm going to keep going. The next part would be this. Ooh, this is a positive 1/2. Right? 1 over 2. So the slope here is a positive 1/2. So the graph of my derivative will be a y value of positive 1/2. So that'll look like this with open circles. And then here, well, I look at my slope because this is the original, so I want to look at the slope so I can graph the derivative. So here, this is a slope of negative 1/2. So to graph my derivative, I make a y value of negative 1/2. And there we have it. You just need to slide this over a little bit. That's what I would do for this. So this part, this stuff, we don't need. Yeah, you just need to slide it over, and then you'll get it right. Hopefully this makes sense. What you're doing, let me write it down actually. Alright, so let's see what I did. First, look at the slope of the original. That's what I was doing. Here, I look at this function. I don't see that it's a y value of 2. I don't care about that. I'm looking at the slope of the original. Because eventually, I want to graph its derivative. And the derivative is the slope of the original. So look at the slope of the original. Either by counting the rise over run, if it's a constant slope like I did here. This is just a slope of 0. That's a slope of negative 1/2, positive 1/2, negative 1/2. This is a negative slope getting closer and closer to 0. So that would be telling if it's negative or positive. When it's not, when it's curved like this, you just have to tell whether it's positive or negative. This is a positive slope of 1. This is a negative slope of 1. So, first step, look at the slope of the original. Either counting rise over run or deciding if it's positive or negative. Then take those slope values, take these slope values that you are counting or seeing if they're positive or negative, and turn them into y values so that you can graph the derivative. Once you turn them into y values and plot them, you will be graphing the derivative. I hope, maybe write that down. I hope that makes sense. If not, we'll just work on it more, ask questions.